Today we're learning about the mean value theorem. I love this lesson. It's fun. All right, the equation is this. F prime of C is equal to F of B minus F of A over B minus A. Means the instantaneous rate of change is equal to the average rate of change. Instant equals average. Okay? Rate of change, ROC. All right, it says F is continuous on the closed interval AB and is differentiable on the open interval AB. Then there exists a number C in AB such that F of C is the instantaneous rate of change. F of B minus F of A is over B minus A is the average rate of change. F prime of C is the slope of the tangent line. F of B minus F of A over B minus A is the slope of the secant line. The mean value theorem states that if F is defined and continuous on the interval AB, it's closed, and differentiable on the open interval AB, then there's at least one number C in the interval such that F prime of C equals F of B minus F of A over B minus A. Prove that the functions are continuous and differentiable. Identify what is given and apply the slope equation. Take the derivative, so you do F of B minus F of A over B minus A. Take the derivative of the original function and set it equal to the slope. Identify C. Rolle's theorem is when A and B are, it says A is equal to B, basically. No, that's a lie. I lied to you. A special case is when F of B is equal to F of A. Because if F of B equals F of A, then the average is equal to 0. And then this is equal to 0. Okay, so that's when your graph looks like this. Here's A, here's B. And it goes like that. It's telling you that there's some point in there where the slope is 0. Okay? What Rolle's is saying is that those all look like Rolle's theorem. What the mean value theorem says is this. Here's A, here's B, and here's the slope of your secant line. Then there's some point C that has the same slope. Okay? Given the function x times x squared minus x minus 2 on the interval -1 to 1, show that the mean value theorem applies and that C, and find C. All right, this is a polynomial. Polynomials, by definition, are continuous, okay? So that means it. So all you'd have to say is f of x is a polynomial. And you can find the derivative, so continuous. All right? And differentiable. Now, what you want to do is find f of b. So b is 1, so you get 1 times 1 minus 1 minus 2 equals -2. F of a equals -1 times 1 plus 1 minus 2, 0. So f of b minus f of a over b minus a is equal to -2 minus 0 over 1 minus a -1. And you get negative 2 over 2, which is negative 1. Now we're going to find the derivative. Well, f of x is really x cubed minus x squared minus 2x. So f prime is equal to 3x squared minus 2x minus 2, and you set it equal to negative 1. So you got 3x squared minus 2x minus, you add 1, minus 1. Factor 3x and x, and 1 are your only options. I need negative 2 in the middle. So you end up with x is equal to negative 1/3, and x equals 1. So this is equal to c. All right, so if you graph that function, the slope of my tangent line is negative 1. My slope of my average rate of change, your secant line, is 1, negative 1. Okay? Same problem. Show the mean value applies on the interval, polynomial, so continuous. All right. F of 3 equals 9 minus 3 minus 6 is 0. F of negative 2 equals 4 plus 2 minus 6 equals 0. So this is really Rolle's theorem, because f of 3 minus f of negative 2 over 3 minus a negative 2 equals 0 over 5. So I take my derivative, which is 2x minus 1, set it equal to 0. So x equals 1/2. Okay. So they're saying at 1/2. So here's my interval. Let's see, negative 2, you're at 0. At 3, you're at 0. They're saying at 1/2, it's also 0. Well, it opens up, so it has to go down this way. There you go. Looks like it's the vertex to me. Negative b over 2a is 1/2. Yep. Okay. All right, here's my interval. Given the interval negative 2 to 3, you have 6 over x here. Show that it applies and find c. Well, MVT does not apply because not continuous at 0. Done. Okay. All right, what about this from 1 to 5? Well, it is continuous because here's the graph. Discontinuity is at 0. Okay. It says on the interval from 1 to 5. So here's 1. 1, 2, 3, 4, 5. Okay, so what's the slope of that line? Well, you go up 1, 2, 3, 4. 1, 2, 3, 4. The slope is 1 of secant equals 1. So the average rate of change equals 1. Estimate point C. I'm going to say right there. You could find it. Find C. Okay. So let's see. So that's 3 minus 5x to the negative 1. So f prime is equal to 5x to the negative 2. And you set it equal to 0. 5 over x squared. What's wrong with that? Oh, it's not supposed to be equal to 0. It's supposed to be equal to 1. There's your mistake, silly. Silly goose. So this should be 1. So x squared equals 5. So x equals positive root 5 because negative 5 is in my interval. There you go. Neat. Square root of 5 is 2 point something. So yeah, we're pretty good. All right, let f be a function that's differentiable on the interval from 1 to 10. If f of 2 is 5, f of 5 is 5, f of 9 is 5, which of the following must be true? Has at least 2 zeros. Let's plot this puppy. F of 2 is negative 5. F of 5 is 5, and f of 9 is 5. Oh. That we don't know. I don't know, the graph is at least one horizontal tangent line. Well, that I would probably say, because somewhere in here it has to have one. So yes, that's no. For some c between 2 and 5, f of c is equal to 3. Well, let's see, would that be true? So 5 minus a negative 5 over 5 minus 2 is 10 over 3? No. So I'm going to have to say 2 only. Is that an option? No. Maybe it's got a typo in it. It seems to me this used to have a typo in it. That this should have been negative 5. Because that brings it down here. And that makes this yes. And this is yes. And that we don't know. So you'd say 1 and... Oh, see, that doesn't work either. Don't know. I think there's an error on this, and I can't answer it. We'll have to talk about it in the Zoom.